In this section 2.1, we will talk about coordinate system, we will talk about lines and their graph. Have you seen any coordinate system? What it does? So we have the coordinate system, and this coordinate system uses the numbers to locate the position, okay? And you all have seen Cartesian coordinate system, and that Cartesian coordinate system has a horizontal line. What do we call that horizontal line? X-axis. We call it x-axis. And this Cartesian coordinate system has a vertical line. And what do we call this vertical line? Y-axis. We call it y-axis. And these two lines are perpendicular to each other. It means they make 90 degree. So here the angle between these two line is 90 degree. And what do we call this intersecting point where two lines meet each other? We call this as a origin, right? We use O to represent origin. So this is the Cartesian coordinate system. It has a two lines perpendicular to each other. The horizontal line, we call it x-axis, and we use x to represent, okay, x-axis. We have the vertical line, that is y-axis. The point where these two lines intersect, we call it origin, okay, that's O. Now this Cartesian coordinate system, it divides our plane into how many regions? So let's take, so this is one plane, okay, so this is a one plane paper, and this plane paper is divided into how many parts? Four parts, right? What do we call these four parts? Do you recall? Right, so these are the quadrants. So we have four quadrants, okay? So this is our first quadrant, this is our second, this is our third, this is our fourth quadrant, okay? Now, if we have, okay, let's say, let's take a point somewhere. Let me take this point. Now, how do we represent this point on a Cartesian coordinate system? What do we use to represent this point on this Cartesian coordinate system? We use an order pair. So order pair means you have two elements. Let me call first element to be x, second element to be y, and inside the parenthesis, okay? So this is an order pair. So in an order pair, you have two elements separated by comma inside the parenthesis, and we use this order pair to represent a point in a Cartesian coordinate system, okay? Now, if we go back to our review section, we had something like 2 to 4. And what was this? How we defined this? Do you recall? This is an interval notation for a set, right? And what this set represent? What this set tell us? So this is a collection of every number which is greater than 2 and less than 4. This is an interval. But now in this chapter, we will use an order pair similar to this one to indicate a point on a plane, okay? So this is not an order interval notation in this case, okay? This is just a point on a Cartesian coordinate system. Now what does this point? Okay, let me take that 2, 4 point. So for example, if our 2, 4 point is here, so this is a point, this is not a set, okay? So we have 2, 4 point. Now what can you say about this point? Where this point is located on a Cartesian coordinate system? So where is this point located? So this point is located how far from x-axis? How far is this point from x-axis? So this horizontal line is our x-axis, okay? So this is our x-axis. Horizontal line is x-axis. Vertical line is y-axis. This is y-axis. Now we have a point 2 4. So this is a point 2 4 on a plane. Now how far is this point from our horizontal line x-axis? 4 unit. Okay, and how far is the same point from vertical axis y-axis? 2. Okay, so every time your first element from an order pair x, we use x in general. For the second element we use y. So first element of this order pair give us the distance of that point from x-axis. Okay, so the distance is this vertical line. So this distance is given by our, is it x-axis or y-axis? So here we have a x, and this is x, or the first element is the distance from y-axis. So this is that x. Okay, and this y, second element, is the distance from x-axis. So this is y. So this is the Cartesian coordinate system. Okay, it has a two lines perpendicular to each other. We have origin and a point xy on the Cartesian coordinate system, means that point is x distance from y-axis and y distance from x-axis. Okay, now we should know how to plot a point. Now if we want to plot a point, let's say we want to plot a point 1 4. How do we plot this point? So we need a number on the horizontal axis and a vertical. So this is origin, so we take it as 0. Then we have 1 2 3 4 5 6. Okay, now what number do we have on the left of 0? -1, -2, -3, -4, -5, -6. Okay, so this is 0 or origin. So this is 1, let me just write down, 3 4 5 6. So this is -1, -2, -3, -4, -5, -6. In a similar way, we take y-axis as a number line, and we have a 0 here, and number on in upward we take it positive. So this is 1 2 3 4 5 6. Now on the downside we have a negative number, -1, -2, -3, -4, -5. And this is something what you have already seen, right? Is this something new for you? No. Okay, now what does this, so if you are asked to plot a point 1 4, now what does this mean for that point? How far is this point from x-axis? Now how we plot this point? Where do we start from? You start from origin. Every time if you are plotting a point, you start from origin. Okay, and you have to move. So let's, okay, so we are at origin. Okay, now so this is our x. First element is always x. It means you move towards x, and your second element is y. You are moving along y-axis. Now so you are at origin and our x is 1. It means we move along x-axis towards 1. Okay, so we are here. Now when you are at 1, you move along y-axis 4 units up. Since it's positive, you move up. So let's move 4 units up. So this is 1 2 3 4. So this point has a coordinate 1 4. So this point is 1 4. Okay, now let's do one more. So if we have something like -4 and -4, so let's plot this point. Again, you start from the origin. Okay, so you are in origin. Now we look at the x, which is -4. -4 means where we are moving. We are moving on the left side. So you move left 4 units along x-axis. 1 2 3 4. Then our y is -4. Since it's -4, we are moving down 4 units. So let's move down 4 units. 1 unit, 2 3 4. And this point has a coordinate -4, -4. Any question? Now what about 5 0? So where will we find 5 0 point? So you start from same like origin. Your x is 5, so you are moving 5 unit on the right. 1 2 3 4 5 unit. Now 0 means you are not moving, right? So your final point is here. So this is 5 0. Okay, so this is how we can plot a point on our Cartesian coordinate system. And since this is not a very new for you, let's go ahead and start the next topic. Do you yes? Oh, okay. Does anyone need worksheet? If you were not here yesterday, then you might be missing this one. Anyone else? Okay. Does anyone need help in plotting a point on a Cartesian coordinate system? You know how to plot this point, right? Okay. Now, the next here is that, so if we connect any 2 points, what do we get? So let's take any 2 points. So we have a, let me call this point P, and its coordinate is x1, y1 in general. And let me call this second point as a Q, and its coordinate is x2, y2. If we connect these 2 points, what do we get? So if we connect these 2 points, what do we get? What is this? Straight line, right? This is a straight line. And the most important feature of a straight line is slope. Okay. Now this slope helps us to find whether our line is rising or falling. Okay. So slope, we use m to represent slope. Okay. So slope is m. It tells us whether the line is falling down or is rising. Okay. And this slope is rise of a line divided by run. Okay. Now, how do we find the rise? So rise means upward. Okay. Run means it's going to be along the x-axis. Now, what is the difference? Okay. Now, our point. Okay. So let's say this is a point, initial point here. Its coordinate is x1, y1, and this is the final point. Okay, you are here and you are moving along this line and you end up here. So this is the coordinate for the final point. Now what is the difference of height here? So your y-axis is, so you are at y1 initially and you are at y2 as your final point. Okay, so rise will be the difference of these two. So y2 minus y1 is the rise, and run is difference of x coordinate, x2 minus x1, x2 minus x1. Okay, so difference of y coordinate is the rise and difference of x coordinate is the run, and this rise over run is the slope of a line. We use m to represent this slope. Okay, now let's take an example here. So here we are asked to find the slope of a line passing through our points. So we have these 2 points. So let's draw these 2 points in a Cartesian coordinate system. So we need x-axis, we need y-axis, we need origin. Okay, so this is 1 2 3 4, 1 2 3 4 5 6, -1, -2, -3, -4, -5, -1, -2, -3, -4. Now let's plot this point. So how do we plot -1, 2? So we start from origin, then we are moving on the left 1 unit, right? So you are here, you move left 1 unit, then you move 2 unit up, 1 2. So this is -1 2. Okay, now let's plot second point, -3 4. So -3, you start from origin, Since it's negative, you move 3 unit on the left. 1, 2, 3, then 4 unit up. So 1, 2, 3, 4. Okay, so this is negative 3, 4. Okay. Now we draw a line connecting these 2 points. Okay, so we have a line. So we have this line, and we are asked to find the slope of this line. Okay, so finding slope means whether our line is falling or rising. Now, since we have a graph, we can clearly see our line is falling down, right? So when you are moving from left to right, so you are here. When you are moving from left to right, our line is falling. So the slope has to be negative. So let's go ahead and find the slope of this line. So we have a slope which is m. This is y2 minus y1 divided by x2 minus x1. Now let's call one of these point as a x1 y1 and another point as a x2 y2. Okay, so let me call, so this is x1 y1 and this is x2 y2. Now what is our y2? So you are comparing. Okay, so here x1 is negative 1, y1 is 2, x2 is negative 3, y2 is 4. So let's substitute y2. y2 is 4 minus y1 is 2 divided by x2. x2 is negative 3. Then we have a negative x1. x1 is negative 1. So this is 4 minus 2, 2 divided by negative 3, negative times negative 1, positive 1. This is 2 divided by negative 2, and we have negative 1. And this is our slope of this line, negative 1. Now here our slope is negative. It means the line is falling down. Okay, every time if you find a slope of a line to be negative, the line is falling down. Okay, when the slope is positive, it's rising, it's going up. Okay, so you are not required to draw line to check whether it's rising or falling. You can tell this from the slope of a line. Okay, if slope is positive, it's rising, it's going up. If slope is negative, it's going down. Okay, so any question on this part? Okay, now let's go to the next one. So the next here, since now we know the slope of a line, the next thing we want to know is we want to know the equation of a line. Okay, and so if we have a line that has a point x1 y1, so let me draw a line. So we have a line, and if we have a point on that line, so let me take this point, and it has a coordinate x1 y1. Okay, so we have a line and we have a one point on that line, and if the slope of this line is m, so m is the slope. Okay, so m is the slope of a line, x1 y1 is a point on the line. Okay, it has to be on the line. If this is the case, then we can find the equation of this line. Okay, we can find the equation of this line, and the equation of the line is given by y minus y1 equals to m times x minus x1. So this is the equation of a line whose slope is m and whose at least one point is x1 y1. So if you have a slope m and a point x1 y1 on the line, then the equation of the line is given by this equation, y minus y1 equals to m times x minus x1. Okay, you do not need to memorize this, you will be given to you. Okay, this equation will be given to you, but you should know how to use. Okay, now let's go to the example and we'll be clear here. So here we are asked to find the equation of a line. So we are asked to find equation of the line passing through 2, 6 and -1, -2. Okay. Now let's draw a line. So we have a line. So let's draw a line. It's passing through a 2 point. So let me take this point as a -1, -2, and this point as a 2, 6. So we have this straight line, and this straight line passes through a point -1, -2, and 2, 6. And our target is finding the equation of a line. Now we want to find the equation of a line. Now, to find the equation of line, we always need a slope of a line. Okay, so let's go ahead and find a slope of this line. So slope is m. Our m is, slope is y2 minus y1 divided by x2 minus x1. Now what is our y2, y1, x2, x1? Now let's call one of these points to be x1, y1. So let's call this is x1, this is y1, this is x2, this is y2. Okay, you can call 2, 6 as a x1, y1. Okay, its slope remains same. Okay, you can call any of this point as a x1, y1, x2, y2. And our x1 is -1, y1 is -2, x2 is 2, y2 is 6. Now let's substitute this number on our slope formula. So y2 is 6 minus, so our y2 is 6 minus y1 is -2. Make sure to have parenthesis. Divided by x2 is 2 minus x1 is -1. So this is 6 negative times -2, that is +2, divided by 2 negative times -1, that is +1. So we have 8 divided by 3. Now our slope is positive. What does this mean? The line is going up. Okay, so line is going up. Our target is finding the equation of a line. Now here we have a slope of a line, and we know at least one point on the line. If this is the case, then we can use this equation to find the equation of a line. Now let's go ahead and use this. Y minus y1 equals to m times x minus x1. Now here you replace your m, replace your x1, y1 by these values. Okay, x and y, it remains as it is. Do not substitute anything for x and y. So we have y as it is minus our y1 is -2 equals to m. Our m is 8/3 times x as it is minus x1. x1 is -1. Now we simplify and we solve for y. So this is y, negative times -2, that is +2, equals to 8/3 times x, negative times -1, +1. We have y plus 2. We distribute 8/3 to x and to 1. 8/3 times x, 8/3x, 8/3 times +1, +8/3. We are solving for y. Okay, it means we subtract 2 on both sides. So we have y equals to 8/3x plus 8/3 minus 2. Now we have a fraction and we are subtracting. We need to have a common denominator. So let's multiply 2 by 3 in the numerator and denominator, since 3 is the common denominator. Now here we have 8/3x plus 8/3 minus 2 times 3, 6, divided by 3. This is 8 over 3x. Now we have a common denominator. We can simplify numerator. 8 minus 6, that is 2 divided by 3. And this is the equation of a line. So y equals to 8 over 3x plus 2 over 3. So this is an equation of a line. So if we have a point, at least one point on a line, and if we know the slope of a line, we can always find an equation of a line. Now, in this equation of a line, what does x and y represent? So we still have that x and y. What does that represent on an equation of a line? Plotting points. Are those any point or are they related to a line? Okay, so we have this x and y. So when you draw a line, how many points we can find on like any straight line? How many points do we see on a straight line? It's infinitely many points, right? So any line, it has infinitely many points on it. And for those infinitely many points, it has their x coordinate and y coordinate, right? And those x coordinate is x and y coordinate are y. So these are the general representation of a point on that line. Okay, so x represent the x coordinate of every point on that line. So here, so we have this line. Okay, so we have this line. This line has infinitely many points. We only took 2 points, but it has infinitely many points on this line, and every point on that line has an x coordinate. Okay, that x coordinate is x, and every point on that line has a y coordinate, that is y. Okay, so these x and y are the general representation of a point on that line. Okay, and this is the equation of a line. Okay, so once you have the equation of a line, you can find all those infinitely many points on that line. Okay, for example, let's take our x equals to be 0. So if our x is equals to 0, we can find the y on that line. So you substitute 0 here. So our y is 8 over 3 times 0 plus 2 over 3. So this is 0 and 2 over 3. So 1 point on that line is 0, 2 over 3. Okay. Now in the similar way, you can take x equals to -1. You can take x equals to 5, 10, or you can take any number. You plot on that line, you find y, and x and y together makes a point. Okay, so with the help of an equation, we can find all those infinitely many points on a straight line. Okay, so here we did find the equation of line. To find the equation of line, you need a slope. Okay, you need a slope, and you need at least 1 point on a line. If you have a slope and if you have at least 1 point on that line, then we use this formula. Okay, we use this equation to find the equation of a line. You will be given this formula. You don't need to memorize, but you should know how to use. Okay, now, okay, any question up to here? All right, now next here, now if we write down our equation of a line in the form of y equals to mx plus b, it means if you are solving the equation of a line in terms of y, like here, so we had our equation of a line, we solved for y, it means our y is by itself on our left side. Okay, then we call that equation as a slope intercept form. Okay, slope intercept form means you are solving that equation of a line for y. Okay, so we have y equals to mx plus b. The equation we had earlier is y equals to 8 over 3x plus 2 over 3. Now let's compare these two. So for y, we have y on the left side. Okay. For x, we have x. What do we have for m? What do we have for m? So we are comparing one more time. So we are comparing this line with this line. Okay. Now on the left side we have y. So here we have y. For x, we have x. Now for m, what do we have? 8/3. So our m is 8/3. Okay. Now for plus, we have plus. For b, what do we have? 2/3. Okay. So this is our b. Now this m is a slope. Okay. And this b is the y-intercept. Now what is y-intercept? Have you heard y-intercept? What does y-intercept mean? Y-intercept means these are the point, every point on the y-axis. Okay, so here our Cartesian coordinate system has a y-axis, it has a x-axis. So this is x-axis, this is y-axis, this is origin, and we have infinitely many points on the y-axis, right? And these points are the y-intercept. Okay. Now, what is one common thing that every point has on this y-axis? Can you think of one common thing that every point on the y-axis has? Is x coordinate is always 0. So every point, okay, on the y-axis has x coordinate equals to 0. Okay, so this point, okay, now like if I go, okay, now here we have a, so here, so this point, what is the coordinate of this point? Our x is 0, y is -2. The coordinate of this point is x is 0, y is 1, 2, 3, 4, -4. So for this point, our coordinate is x is 0, y is 1, 2, 3. Okay, so every point on the x-axis has a x coordinate 0. Okay, this is the common thing. In the similar way, we have a x-intercept, and x-intercepts are the point on the x-axis. So every point on the x-axis, we call these are the x-intercept. Okay, and what is the one common thing every x-intercept has? Its y coordinate is 0. Okay, now if we go back here, so let's find the coordinate of this point. Our x is 1, 2, 3, 4, 5, 6. So x is 6, y is 0. For this point, coordinate is x is 1, 2, y is 0. For this point, our x is -1, -2, -3, y is 0. For this point, x is -1, -2, -3, -4, -5, y is 0. Every point on the x-axis has a y coordinate 0. Okay, every point on the y-axis has x coordinate 0. Every point on the x-axis has y coordinate equals to 0. Okay, now if we have a straight line, and if we know the slope of a line and its y-intercept, so let's draw a line. Okay, so we have this line, we know the slope of a line is m, and the y-intercept means it's the point where the line crosses y-axis. So line crosses y-axis at this point. Okay, and the distance of this point from origin is b. We use b to denote. So b is the y-intercept. So if we have a slope m and a y-intercept of a line as a b, then the equation of a line is y equals to mx plus b. So this is the equation of a line. We have a slope m, we have a y-intercept b, then you substitute m, you substitute b in this equation, then you will get the equation of a line. Okay, so this is slope intercept form. So this is slope intercept form, and the one we had earlier. So earlier we had y minus y1 equals to m times x minus x1. So this is point slope form. Okay, so this is, so we have a point and a slope. So this is point slope form. Okay, and this is slope intercept. Okay, yes, slope intercept form. And both of these are the equation of a line. Both of these give us the equation of line. Okay, so every time if you are asked to find the equation of line, you have these two options to find the equation of line. You will be using slope intercept form or point slope form, and it depends on what information we are given to us. Okay, now let's go to an example. So here we have to write down the equation of a line. Okay, we are finding the equation of a line with a slope of -4. So our slope is -4. Slope means m is -4, and y-intercept of 0 square root of 2. So how do we represent y-intercept? We use b. So our b, which is y-intercept, that is square root of 2. Okay, so this slope is m, y-intercept is b, and your b is the y value, okay, which is the square root of 2. And we are asked to find the equation of a line. So as I said earlier, every time if you are asked to find the equation of a line, you have two options. Your first option is using y equals to mx plus b. Your second option is using point slope form, y minus y1 equals to m times x minus x1. So you have these two options. Now which option will we use here? Which one is the best for us? So we have the y equals to mx plus b. We have y minus y1 equals to m times x minus x1. Okay, now these are the two options. Now what is given to us? M is given, b is given. Now which option has m and b? 1. Now we use the very first to find the equation of a line. So let's write down that y equals to mx plus b. Now you replace your m by -4 and b by square root of 2. So y as it is. For m it is -4, x as it is. Our b is square root of 2. So this is the equation of a line. Now since the slope is -4, what can you say about this line? Is this line going up or going down? Going down. Okay, now it's going down, -4. Okay, now how we draw a graph with these two information? So we need to have a Cartesian coordinate system. Okay, now our y-intercept is square root of 2. Now what does this y-intercept? This is the point where line crosses y-axis. So square root, let's say this point, this is square root of 2. Okay, so this is the point where line crosses y-axis. Okay, our slope is -4. Now what does this mean? How we defined our slope? Slope is rise over run, right? In our case, what is rise? Rise is -4. What is run? 1, right? If it's nothing, it's always 1. So our rise is -4, our run is 1. Now So we are at this point, we are at y-intercept, we are trying to graph. We are at y-intercept, our slope is -4. Now it means you run 1 unit on the right from this point. So you are here, you run 1 unit right, then your rise is -4. Rise is -4 means you are going down by 4 units. So this is 1. So you are starting from y-intercept, okay? You are starting from y-intercept. You are always running 1. So your run is 1. So you run 1 unit. Since it's positive, we are running right side, okay? If your run is negative, we are running left side. Our run is +1, so you run 1 unit on the right. Rise is -4. It means you fall 4 unit down. So 1 unit, 2 unit, 3 unit, 4 unit. So this is your final point. Okay, you connect these two dots and we get a straight line. And this is a graph for this line. So using slope and y-intercept, we can graph a straight line. Now let's practice one more graphing here. So let's use our previous equation. So we had y equals to 8/3x plus 2/3, right? Now, so this is the equation of a line. Now let's graph this. You draw your Cartesian coordinate system. Where do we start from? We always start from the y-intercept. What is the y-intercept for this line? So you compare this with y equals to mx plus b. Okay, your m is, slope is 8/3. Your y-intercept is 2/3. So let's start from y-intercept. So 2/3, let's say somewhere here. So this is 2/3. Okay, so we are starting from 2/3. Now how do we move from this y-intercept? It depends on our slope m. Slope is 8/3. How do we define slope? Slope is rise over run. So what is run? Run is 3 unit. So you run 3 unit right, and then you go up by 8 unit. Okay, so you are at y-intercept. You are at y-intercept. So this is 1 2 3 4 5. 1 2 3 4 5 6 7 8. Okay, so you are here. Now you run 3 unit right. 1 2 3. Okay, you run, always run first, then you rise 8 units. Since it's positive, you are going up. Okay, 1 2 3. Okay, 1 2 3 4 5 6 7 8. Okay, up to here. Now you connect these 2 points, we get a graph for that line. Okay, so this is a graph for this equation, y equals to 8/3x plus 2/3. Any question? So let's practice. I'm sorry? This point? Yeah. So this is the y-intercept, 2/3. You always start from the y-intercept. Okay, so this is the 2/3.
What was the y-intercept for the first one?
You mean this one?
Yeah.
So we had our y-intercept as a square root of 2.
Where is it on the graph?
Here, this point. Okay, so let's practice one more. So let me take some. Okay, can you try this? Y equals to -4/3 x plus, okay, not -3. Okay, I want you to graph this equation of a line.